Okay, welcome to section 2.4 part 3. The reason why there's so many parts in this is we have a bunch of different goals. So the first two videos covered points, so form and standard form, and now we're going to learn a third part of this, which is to graph using the x and y intercepts. And you can do this all the time, but it makes the most sense when you have something in standard form. When you have x and y on the same side, you can graph it pretty quickly by finding the x and the y-intercepts. And again, this should just be a review. But yeah, that's what we're doing in this video. All right, so the first part of this is just what are intercepts? All right, so I think the Xavier roads here, and so intercept the ball means like you cross into the path of the ball. So for us in intercepts, it just means it's where we cross on the x and the y axis. Okay, so the point highlighted right here would be called the y-intercept because this is our y-axis and our line crosses the y-axis right here. And so this is just an xy point, specifically the x is 0 and the y is 3. All right, and so a y-intercept point, any point on this y-axis, actually the trick will be is that this x coordinate will always be 0 for a y-intercept. Right, so just as an example, we picked another point on the y-axis, say this one down here, that would be 0 and 1. I'm just picking it randomly just to show you that any point that's on this y-axis always has an x coordinate of 0. All right, so the important part for y-intercepts is the x is 0. All right, so similarly, if we have our x-axis, maybe I'll do a different color here, but an x-intercept will have an x value, so like in this case, -9 and 0. Okay, and so what happens for an x-intercept is the y coordinate is 0. Right, so here's our y coordinate 0, so I pick another one right here, be -3 and 0. All right, so when we're finding an x-intercept, the y coordinate will be 0. Okay, so to help you remember this, you might want to jot it down. So defining the x and y intercepts for an equation, to find x-intercept, you have y be 0. Okay, so that's what's shown here on the right, is that to find an x-intercept, you have the y coordinate be 0. And similarly, to find the y-intercept, you set x. All right, one other quick note here is, so this y-intercept, we've talked about this before, right? So I actually have an equation up here where like this is slope-intercept form, and this number right here, this 8, that is the y-intercept. Okay, and that's why having it in y equals form, the slope-intercept form, is kind of nice because you know the y-intercept already. Okay, but just to apply our concept from up here to the problem below, just to make sure that the y-intercept is 8 like we'd expect, what this says is to find the y-intercept, you set x to 0. So if I go down here, I'm going to basically do an xy point. I'm going to do x of 0 and find the y coordinate. If x is 0, it's 3 times 0 plus 8. So that's just going to be 0 plus 8, and y is just going to be 8. All right, so that kind of matches what we thought where the y-intercept is 8. It's just kind of another way to find it is using this trick up here. Okay, and again, this trick in general we have is going to work for standard form. All right, so the next one to get down in your notes that definitely would have this example here is we want to graph it, right? We want to make the graph. And basically the idea is we're just going to find these 2 points. I'm just going to say, boom, it's here and here or something, and then connect the dots and make a straight line. All right, so that's the concept, is we're going to use those 2 intercept points to make our line. Okay, so the way I kind of do it is say, okay, to find a y-intercept, that's going to happen when x is 0. So I just go like this and say, okay, let's make x 0 and figure out what is y. Okay, and so if x is 0, you'll get good at this to maybe basically do it mentally. But if I put into the equation a 0 right here for x, y will be, let's see, it'll be 0 plus 3y equals 6. And so then you just divide by 3 and you get y to be 2. Okay, so that gets us the point where we cross in the y-axis, is 0 and 2. All right, so now we just do kind of the reverse process to find where it crosses on the x. We're on our x-axis now. We want to find where it crosses there. Now we make y 0 and find x. So going back up to the equation again, y being 0, so -2x plus 3 times 0, which is going to be 0. And you'll see, oh, we get the statement negative 2x has to equal 6. And then just divide by negative 2, and we get x to be negative 3. Okay, and so we can plot that point. And there's negative 3. So we've got our 2 points, and now we just have to use our dot connecting skills, which my handwriting is not very good, and I missed it, but generally just draw a straight line between those points, and then we got our graph. Okay, so this is called graphing with the x and y intercepts, and I'm going to do one more example where I'm going to contrast the two different methods. All right, so this is again mostly useful for the standard form where x and y are on the same side. So I got one more example for you. So we have a standard form equation, and we can graph it like we just did with the x and y intercepts. So maybe pause the video and do that quick, actually. So I'm going to show you this first method, and then we'll talk about the other method, which we did the other day. So using the intercepts, right, I'm going to make x 0 and find y. All right, so and basically when x is 0, this just goes away, right? So we just end up with this statement of negative 5y has to equal 15. If we divide by negative 5 there, we get negative 3. Okay, and so I'm going to go ahead and plot that point right away. Negative 3, 0. All right, now I just got to find the other intercept. And it's a different color here. So the other intercept is the other 0 point. So this time, instead of having x be 0, make y 0, find x. Again, when y is 0, 5 times 0 is going to be 0, so this just goes away. So we get 2x has to be 15, divide by 2, and so we get 7.5 for our x-intercept. Okay, so now I'll go down and just plot that point. 7.5, there's 3, there's 6, 7, so 7.5 would be right about there. And now just connect those two dots, and boom, we've got our line. Okay, so that is one method, right? But we could also use what we did the other day, right? Which is to just solve this and put it in slope-intercept form, because when you have it in that form, you know the slope and you know the y-intercept. So, for example, here we just got to get y alone, which is just a couple quick steps. Take away the 2x. Negative 5y equals 15 minus 2x. And then divide everything by negative 5. So you get y equals negative 3 plus 2/5 x. The negative divided by negative makes a positive 2/5. Okay, and so you'll see that we'll graph and we'll get the same thing we got on the other side there. Okay, so we're going to start at negative 3, and our slope is going to be 2 to 5. So up to 1, 2, 3, 4, 5. Okay, and connect the dots, and we get the same graph as the graph we got on the right. So just as a summary, there's two ways to graph out of standard form. I think the intercepts is easier once you get used to it, but if you like graphing using slope and y-intercept, that's okay too. I know on the test, I think there is one where you have to graph using the intercepts, so you have to know that at least for this test. But after that, going forward, you can kind of do whatever method you want.